Hi, today we're going to solve another variant Sudoku. This one is simply killer cage rules. Hardly feels like a variant, how common this is. I am a huge fan of killer cage puzzles, so I want to get going. Let's get going. Uh, huh. Not a lot of obvious starting points. I see lots of multiples of 7, so I'm thinking, of course, there's 3 ways to make 7 with 2 digits, that we're going to be coloring the different ways of making a 7 pair quite a lot. There's 2 ways to make 14. I'm also seeing a lot of 14 pairs. How many ways are there to make 21? Obviously 876, 975, and then I think 984. So 3 ways to make 21. 28 in 5 digits is leaving 17 in 4 digits. Is that right? Like, let's suppose this is 876. We know there's a 9 that's not in the 7 cage. There's 2 ways to make the 7. There's a 1 that's not in the 7 cage, and then the other, yes, what did I say the 3 ways were? 876, 975, and 984. So the 21 cage has either a 4, a 5, or a 6. And then the 7 cage has either a 4, a 5, or a 6. And so there's 6 ways to make those choices, and each way fills out uniquely. Okay. 21 cage. How does it interact with 10 cages? I'm gonna just want to see these. Okay, so this one, the 10 cage, would be a 9-1. This one, the 10 cage, has 2 possibilities, the 2 even possibilities. And this one, the 10 cage, would be 7-3. So there's 4 ways to fill out these cages. Still quite a few. This 10 cage, of course, has to be quite small, but it doesn't seem to really interact with other cages in the grid. Like maybe this cage, and this cage, but it's hard to call that much interaction at all. — 17 and 4 is reasonably small. It can't have an 8 or a 9. Right? No, 17 and 5 can't have an 8 or a 9. 17 and 4 could. 9, 1, 3, 4 or something. 2 different ways to have a 9. (21) in 4 digits. It's pretty unconstrained. If this were 8-6, that eliminates one possibility. If this were 9-5, that eliminates another possibility. 26 in 4 digits at least is somewhat constrained. There's 5 7 cages in the grid. There's 14 cages in the grid. What's the central idea? And maybe center is an important way of thinking of it. These two 21 cages can't have the same digits, or else the 10 cage would also be 21. I'm going to once again, enumerate all the possibilities to make this easier to consider. Any digit in common here must show up in the 10 cage. If they both have a 9, and there's a 9 here, this is clearly nonsense. If they both have an 8, again there's a 9 here. So that means there is neither of these is 4, 8, 9. One of them is 6, 7, 8, one of them is 5, 7, 9, and therefore there's a 7 in the middle. It's our first actual progress. Both of these have a 7. If this is 6, 7, 8, then this is 9, 1. If this is 5, 7, 9, this could be several possibilities. There's very little stopping this from being 3, 4. Maybe I should ask, where are 7s in the grid? We've got 5 7 cages and 5 14 cages, and none of those can have a 7. That's not terribly restrictive. What happens if we have a 7 5 here? That means this is 6 8. Maybe 9s will be interesting. I'm not sure about that. If these two are the same, then they appear here, because these two are obviously not the same. If these two are the same, they appear here. If they're 5 9, you can have 5 7 6 8 9. You can have 9 3 5 6 8. If they are 6 8, you'd have to have 4 8 6 5 9. If this is 6 8, that makes this a 4, and this a 5 2. Let's jot this out. Is that correct? No 6, no 4. This has to be 5 2. Now this must be 3 4. This is 5 9. That all looks fine. of these is 4. This is odd. This is not A2. This is not 6-1. Does these being the same cause problems? Not really. Probably there's an issue with these two being the same. Because it does something like forces them to appear here, and that, like if these are 6-8 and these are 6-8 and these are 6-8, then this is odd. The 21 cage has to have at least 2 digits that are 6 or higher. The 10 cage has at least 1 digit that is 6 or higher. So certainly these two can't add to 14. Maybe there's an easier way to do this. 21 plus 10 is 31. These 4 add to 14. So certainly these 2 do not add to 14. But if these are the same, it could just be this is 14. In fact, it's forced that this digit is one of the ones on the 14, which means it's not the 7, which means that it is either 9, 6, 8, or 5. And we know it's not taken from 6, 7, 8. Sorry, we know it's not taken from 4, 8, 9. So it is either 5, 6, 8, or 9. Well, that's unconstrained if there ever was unconstrained. Oh, no, wait. Okay, so these 21 cages, they contain a 7 and an implicit 14 pair, the 2 digits that are not 7. So these two can't be equal, because if they were equal, they can't appear within the cage, because this is clearly impossible, no matter how you try to slice it, because the remaining digits have to be here. And it either appears entirely within the 21 or entirely without the 21. So they have to be here. And that's, of course, impossible because that makes these 2 digits add up to 0. So we know for sure, and this is without, I've drawn all these pencil marks at the bottom, but ignoring them, we know for sure these are unequal. Now, given the pencil marks are drawn at the bottom, that would make this 5, 9. And that would make this one 6, 8, which goes here. And the 10 can have no 9, no 8, no 7, no 6, which is impossible. Okay, so I'm pretty sure that is going to be our opening. This is very clever. And we can delete that because the 21 cages are not that. Okay, so we know there's a 14 pair. We've established before these two are not the same 14 pair as each other. One of them is the same as this 21. So this cannot be 7. To illustrate, suppose this is 7 These add to 14. This pair has to either equal this or this. Either way, we have a triple that is actually a pair, so that's clearly not 7. Okay. Now, if this is 5, 9, why did I deduce that there had to be 6, 8 here? I think all I've done is deduce that this is a 7. If this is a 7, then this pair is distinct from this pair. So these 4 digits include 5, 6, 8, and 9. That means the 10 can only contain digits that are 4 or smaller, which is impossible. So I know for sure that this is a 7. And I think we will start doing coloring. And I predicted I was going to do coloring with 7s, but actually we're going to do colors with 14s. So those digits are all the same. Those digits are different from the cyan digits. And the cyan digits, if they are 6, 8, then this is 9, 1. If they are 5, 9, then this is even, but unconstrained. The peach, these are peach appear in here. So if these are peach, then these are peach, and this is 7, but we don't know that. Peach digits appear in here, that means peach digits appear here, right? None of these can be peach. And these are cyan, and then these are cyan. Now, it is possible for cyan digit to appear in the 7. If it is a 5 or a 6, then this would be 1 or a 2. I want to have something happen by assuming that these two 7s are the same as each other, but it seems unlikely. Well, these have to be peach, clearly. Now, if this is peach, this is cyan, these are cyan, these two are not peach. That makes these two peach and these two peach. Seems perfectly fine. These two 10s can't be the same as each other because this one has a peach digit and this one does not. And these two 10s see cyan. I wonder if that makes this a 7, 3. If peach is 5, 9, that makes this one 9, 1. This is 6, 8. Oh, yeah. Okay, so this 10 sees all 4 digits from 5, 6, 8, 9. That means it must be 7, 3. That means that must be 7. which tells us this is not 7, 5. Can be 8, 4 or 3, 9. 8, 4 or 3, 9. Either way, it has one of the peach or cyan digits. Three, 9 is slightly obstructed by this, but not fully obstructed. Each of the deductions we've made so far has really felt like it came out of nowhere. I keep being surprised by where this puzzle is going. None of these can be 3. None of those can be 3. This has to be, these have to be 1, 2, this has to be 4. That makes this one 8 or 9, and this one 5 or 6. Here's a 3. Now this can't be 4 or 8. There's a 3 up here, and here. There's a 4 here, and a 4 here. This is looking a lot like 3, 4. This can't be 3, can't be 4, can't be 5, can't be 6, can't be 7. It is 8 or 9. And whatever it is, that makes it a cyan digit. Makes that a 1 or 2 from the column. So this is 1, 2, 5, 6. In particular, it has the cyan 5, 6. And then the peach 5, 6 has to be here. Yeah, okay. Filling in a few digits here and there. There's an 8, 9 in here somewhere. This can't be 3, 4. That feels very significant. So this sees 4 different digits from 1, 2, 5, 6. Therefore, it can't be 1 or 2. I don't think that particular deduction is going to matter, but you know, a deduction's a deduction. So I think that, so obviously these pairs are different. So this must contain the peach 5, 6. Which means this is 5, 6. And since this has the peach 5, 6, and this has the peach 5, 6, it doesn't appear here, so this is cyan. Make this peach, which actually we knew from this already. So this one is 5, 6, this one's 8, 9. Ah, and then that makes this the 3, and so it is not 3, 4. This is 5, 6, this is 8, 9. think 1, 2 also belongs up here. And then the last the cyan 5, 6 in this row has to be here. Making this 1, 2, 3, 4, but not the 3. One of these two has to be 4. Otherwise you have difficulty finishing this. This contains the peach 5, 6, specifically here, right? We have a 1, 2 in the row. There's a cyan 5, 6 here. These are stray marks. And this has to be 7. It sees 1, 2, 3, 4. It sees all the cyan and peach digits. This can't be 5, 6. I think it is time to institute a more expanded coloring. So I'm going to use cyan and peach also for the 1, 2s that add to 7 with the 5, 6 of the same color. So I'm now saying there are 3 cyan digits and 3 peach digits, a 1, 2, a 5, 6, and an 8, 9. The 8, 9 do not add to 10 with the 1, 2 of the same color but of the opposite color. Which you can see because this digit, it appears in this column. The cyan 1, 2 is here. The cyan 1, 2 has to be somewhere in this column, and it's clearly here. This has to be 4, right? I guess we could put 3, 4 in the mix, but this is the only 12 cage in the grid, so I don't think it's worth doing that. This is the only place for 8, 9. And then this is the only place for peach. Wow. Peach 1, 2 is here or here, as is peach 8, 9. I'm saying this cell can't be peach because it sees 3 distinct peach cells in the row. And it can't be cyan, and it can't be 3, and it can't be 7, therefore it's 4. So both of those are peach. We do not know what order. It's really interesting how this puzzle is working out. Okay. 3 peach, 3 cyan. 3 peach, 3 cyan. 3 peach, 3 cyan. 3 peach, 1 cyan. Where is the 8, 9? Anywhere. Where is the 1, 2? Likewise. Okay. 3 peach, 3 cyan. 3 peach, 3 cyan. 2 peach, 2 cyan, and then also the 1, 2's in the middle. Right? 3 peach, 0 cyan. Cyan 8, 9 is here. Cyan 1, 2 is here, as is cyan 5, 6. So we have 1, 2, 3, 4. No. No, okay, let's fix this. We have 5, 6, 1, 2. So the 1, 2's are finished. That leaves 3, 9, and 3 and 4, and either 8 or 9. And you can't have these two both be cyan. Or this can't be 5, 6 and this be 8, 9. Because that would fail here. I suspect the next frontier is here. This 7 could be 3, 4. Can't be peach. Could be cyan. No, it can't be cyan because these two add to 7. They are the cyan pair. So this is 3, 4. Very interesting. I mean, we finished. Yes, that does. You have not 3, not 4, not 7. So a 1, 2, and 8, 9 of opposite colors, as these are of opposite colors. Which opposite colors? Unclear. Yes, unclear is the correct answer. We established this is not the peach. 5, 6. 5, 6 in the column. Not as useful as one hopes. I know neither of these is cyan 5, 6. So it's here or it's here. Cyan 8, 9 can be multiple places, as can the 2, 1, 2's. Well, we know the 7 goes here. That's something. Or it can go there as well. So what do we have in this row? Between 1, 3, 4 and 1 cyan digit. Well, this is certainly no cyan digit because of the column. It has 3 cyan digits already. In fact, we know this is a 3, 4 pair if I'm just looking in the columns. So this is not 3, 4. It is an unknown cyan digit. either 1, 2, or 8, 9. There's one more 3, 4, and one more cyan. This is going to interact in a strange way with this 10, I'm sure. And then suddenly the whole grid will resolve because of it. Just looking to see if I can extract useful information from... there's this. This is going to tie the 3 4s to the cyan peach resolution. Okay. Now this is 8, 9, this is 5, 6, therefore this is not 5, 6. Did I do that right? 8, 9, 5, 6, 6, 7. There must be a peach 8, 9 here. Kind of want another color for 3 4s just so I have everything colored in. What would I use? This digit equals this digit, I think. This has a cyan 8, 9. Right, we found the 8, 9s. It's a peach 1, 2. Cyan 8, 9. That's no cyan 8, 9. One, twos are found in this column. This contains a 3, 4, and 8, 9. Unclear which one is the cyan 8, 9. Feels like we have everything. Okay, now we can be a bit better. We can work out this has to be the 8, 9. This has to be the 5, 6. This has to be the 3. Okay. 4. Oh. 3, 4, 3. I think we have all the 3s and 4s. Yes. And critically now we have that cyan highs are 9. And then cyan mediums are 5. And then cyan lows are 2. If I can find the 2. I feel like I haven't been explaining my reasoning very well, but this has mostly been I don't know what this has mostly been. Okay. Now peach highs are 8. It feels like every single step has been simple. I mean, once you find it, it's been simple. And had nothing to explain. Well, that's concerning. What am I missing in this box? 1, 2, 3, 6. I'm missing 6. This is supposed to be... Okay. Let us not despair. Let us simply go backwards until the contradiction goes away. It must have been when I started filling out the 3s and 4s in the central box. Yeah, I already have a problem with the 5, 6. Ah, here it is, right? Oh, it's worse than that. Ooh. 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 Neither of these can be 8, 9, nor 5, 6. So I made an error earlier than this. Not infeasible to go... Yep, still a contradiction. Put that back. Still a contradiction. The contradiction is these 2 digits are all here. Right? They see in this box all of this, and they're not this, so they must be there. So in box 2, when I filled this out, did I do it wrong? Okay, the contradiction has gone away. I need this to be peach 8, 9. Let's just go back a little bit further. Okay, good enough. Peach 5, 6. Peach 8, 9. This has a peach 8, 9 and a blue 1, 2, forcing this to be 8, 9. This digit is equal to this, and this, and this. So together they see all of that. That's 3 cyan digits in this box, so this is a 4. Really hoping we evaded our errant contradiction this time around. Eight, 9, 8, 9. This is 8, 9. This has to be peach 1, 2. I think this is the same positions I had the 7s in last time. And then this is cyan 1, 2. That looks good to me. This sees both 1, 2s. So it is peach. I think this solves all the way now. I don't see any rows or columns or boxes where I'm seeing 2 of the same digit. It's now a matter of filling them in. Okay. A little bit tedious on the way down. So cyan is going to be 9 and 5 and 2. So just have to 5, 9, 2, 5, 2, 9. It was fundamentally a coloring puzzle, and everyone likes coloring puzzles. Okay, now we need 8, 6, and 1. I remember some of the very first puzzles I saw on Cracking the Cryptic were coloring puzzles, and I've liked them ever since. Good puzzle. I enjoyed it quite a lot. I like killer cage puzzles, and this is no exception. Alright, thanks for watching.